Morning guys. Our topic for today is all about torsion. So what is torsion? Consider a bar to be rigidly attached at one end and twisted at the other end by a torque or twisting moment T, equivalent to F times D. So F is the force and D is the distance, which is applied perpendicular to the axis of the bar as shown in the figure. So such a bar is said to be in torsion. So in short, torsion daw is a twisting moment. So nagtitwist yung ating material. For the torsional shearing stress, for a solid or hollow circular shaft subjected to a twisting moment T, the torsional shearing stress tau at a distance P from the center of the shaft is equivalent to tau equivalent to T, P divided by J, where T is the twisting moment and P is the distance from the center of the shaft and J is the polar moment of inertia of the section, and R is the outer radius. So for tau max is equivalent to T times R divided by J. Then for the materials such as solid cylindrical shaft, so for the polar moment of inertia, our formula would be pi divided by 32 d to the fourth. Then for the tau max, equivalent to 16t divided by pi d cube. Then for hollow cylindrical shaft, so J, or the polar moment of inertia, is equivalent to pi divided by 32 times d to the fourth minus, or d to the fourth, which is the outside diameter, and minus d to the fourth, which is the inside diameter, so the smaller d. So tau max is equivalent to 16td divided by pi times d to the fourth minus d fourth. For the angle of twist, the angle theta through which the bar length L will twist is T times L divided by G in radians, where T is the torque in Newton per millimeter, and L is the length of shaft in millimeter, and G is the shear modulus in megapascal, and J is the polar moment of inertia in millimeter to the fourth. D and D are diameters in millimeter, and R is the radius in mm. So ayan yung for angle of twist. Then next, so for the power transmitted by the shaft, a shaft rotating with a constant angular velocity omega in radians per second is being acted by a twisting moment T. The power transmitted by the shaft is equivalent to P equivalent to T, which is the torsional moment, and omega, which is the angular velocity, equivalent to 2 pi times T times dF, where F is the number of revolutions per second and P is the power in watts. So that's all for the principles behind torsion. Then next is for the problem solving.